5 microfarad capacitor is initially charged to 12 volt. So capacitance is 5 microfarad and it is initially charged with a 12 volt battery. Let's say initially we have a capacitor who is connected like this by a battery V, capacitance C. Then the charge appear, let the charge appearing be Q, and it will be like it is having the positive charge and it will be having a negative charge. Now after the positive plate of this capacitor is now connected to the negative terminal, so the situation changes to capacitor connected with such a battery, such that a positive plate is now connected to the negative terminal of the battery. Potential is same, and now the charge will appear, will again Q, because capacitance is same, but the polarity will be changed. That is, now this plate will be having negative charge and this plate will be having positive charge. So we have to calculate the net charge flown. So initially we have initially Q charge over here. Now for say that in this direction electron flows, fine. If I say that in this direction electron flows and we want a charge of minus Q over this plate, and initially we have plus Q, so the charge that we have to flow to make this plate negatively charged with a charge of minus Q, so the charge that has to be flowed will be equal to Q minus minus Q, that is 2Q. So the energy, that is initial energy of the capacitor, will be half of Q square by C, and final energy will be minus of half of Q square by C, because now the polarity is changed, so heat developed will be E final minus E initial. So we have minus of half of Q square by C minus of half of Q square by C. That comes out to be minus Q square by C, or it can be written as minus of 2 times of CV square. On substituting the value, we have minus 2. Capacitance is given to me as 5 microfarad and potential is 12, that is 12 into 12. So the answer comes out to be 1.44 millijoules with a negative sign. This negative sign simply shows that heat is lost. Heat is lost. That is our answer.